अरे यार हम लाइव है क्या नहीं। हाँ है। अब हम शायद लाइव है ना। ओके सो लाइव, सॉरी, ओके सो गाइस वी आर लाइव। मैं भी म्यूट पे बोल रहा था। तो मैं ये बोल रहा था कि जो मैं कोर्स फॉलो कर रहा हूँ डीएसए सीखने के लिए, वो एक पेड कोर्स है। और पेड कोर्स में लाइव स्ट्रीम में नहीं दिखा सकता, बट उसका ऑडियो जो है वो डेस्कटॉप से आएगा, तो आप ऑडियो सुन सकते हो। बाकी मैं मेरे नोट्स यहाँ पे नोशंस में निकालने वाला हूँ, और साइड बाय साइड अगर कोड करना हो तो वीएस कोड में भी कोड करने वाला हूँ। सो ओके, लेट्स गेट स्टार्टेड। ओके सो लेट्स स्टार्ट द कोर्स।
So is my screen visible to everyone? Can everyone see my screen? This introduction to C++ and this red pen also. Is everything working fine? Yep. Great. So guys, welcome to your very first class of programming. So how many of you are learning programming for the very first time? Give me a yes or no. Okay, I can see a lot of no's. So you guys are like humans. It cannot think. The hello world ended. This got printed. Bracket will always choose which data type. तो सब कुछ खाली है, हमें इनपुट यहां मिल रहा है। ओके, तो now I've written this scene on two different lines. Again, I will also open this my submissions page. So you will see an accepted verdict here that all test cases I need to use cin. So I'll do cin. Then 3. No, it is false. Is 5 greater than 9? They may ask you for your work email ID. And based on that, the work email ID is valid or not, you will get an account or you will not get an account there. Okay. There may be certain places that you may, let's say, simplest use case of if else. Let's see one more complex use case of this. Let's solve one hard problem on this. Anyone spot the mistake in the revision sheet that we discussed similar for this for lead code? Pointers. Okay. Let's do things at the right time. This is not the right time to do. So language module is still this part. Pointers, pass by value, pass by reference. This is still the language. This is the language C++ module. We start DSA from this point. The actual DSA from this point. So after this point, things will be language independent. Here also things are logic will be again independent to the language. But yeah, because people are just starting out, so they need something to learn as well, right? Otherwise, how they will do DSA in without any programming language? So this is the first module of C++. From here DSA will start. So after this point I will keep on giving the references कि यार Java में कैसे होगा, उसमें कैसे. Hi everyone. Here we get 5 rows, each having 2 stars. Rows will be equal to number of columns. Yes. That print except all of them are what? Okay. Now we have to learn to print the value of things are getting messed up. Okay. Let's submit. Asked to store the marks of 10 people. Again, you can write one C in. So when this array has been created, at every spot, what value will be there? First of all, store all these elements and then print them on. Print. Write the same loop in a better. Yes or we have to sort this data or print this data in ascending order. Swap, we get 8, 7. Now we need to test whether A of I is our answer or not. Broad-based company after this bootcamp if you follow it sincerely. Okay. The answer. Check for 2 entire array. Count is 1 answer. Yes. If somehow we are able to get that count, if somehow we are able to get this count, we have our answer. We have our answer, right? If you see here, what we have to just and break also from. Easy है, not that difficult, solvable है. So do not get scared when you see these nested loops. All right. So Karan asking when I will introduce TC and space complexity. So currently we are in the phase where we are learning a language. We are learning fundamentals कि यार C++ होती क्या है, variables क्या है, loops क्या है, array strings and all that. Once we cover that phase, we'll start with this actual DSA, that is time and space complexity. Do not worry about that. If element is coming twice, will that twice coming element is coming just one time and other coming twice? So Amrita, if you read the question carefully, so it says you are saying if element is coming twice, will that twice coming element is coming just one time or other? Not able to understand what you are saying. Yes, Pratik, you can crack any product-based company after this bootcamp if you follow it sincerely. Okay. Okay. Yes, next weeks we'll do strings or maybe 2D arrays. So I'll let you guys know. Most likely we'll do strings only next week. Okay. Great. Let's solve some. So did you guys participate in yesterday's contest? Missed it? Okay. Yes. Great. So people who were not able to attempt it, now you can attempt it as well. You can find the problems in the same group. Okay. And people who gave the contest, do you want me to discuss any of the problems? I think maybe the last one, the arrow one. We'll pick some last problems from the contest and discuss that as well. Okay. Today we'll be starting with functions. We'll start in a couple of minutes. Let everyone join. There's a lag. Video blur. Okay. Let me check. The internet is fine or not. Speed is I think fine. Increase the quality of video. I think it's already. Let me try once again. Is it fine now? Yes. Okay. Some are saying yes. Some are saying no. as that's the best I can do right now. So we'll start. Okay. So I'm closing the chat and we'll start with our today's topic, that is functions. Okay. So let me share my screen. All right. Can you guys see my screen? Yes or no? Just give a reaction. Yep. Great. Chalo. Let's start. Today's topic is functions. Okay. Today we'll start with
What is the
functions.
voice?
Before we start with functions, let's solve a very simple problem. You might have solved this in your assignments. This is factorial, right? So I hope everyone knows what factorial. Factorial is, if you want to find n factorial, the formula for that is n into n minus 1 into n minus 2 till 1, or you can write it the other way around also, key 1 into 2 into 3 till n. This is basically n factorial. Let's say if you have to calculate
मैं जस्ट चेक कर रहा हूँ क्यों मेरा वॉइस फैन का वॉइस आ रहा है शायद. फैन का वॉइस आ रहा है क्या? थोड़ा 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 फैन का वॉइस आ रहा है गाइस शायद. इट्स ओके, इतना भी नहीं है तो चलिए स्टार्ट करते हैं.
3 factorial. That will be 3 factorial 2 minus 2 till 1, or you can write it the other way around also, key 1 into 2 into 3 till n. This is n. This is basically n factorial. Let's say if we have to calculate 3 factorial, that will be 3 into 2 into 1, that will be equal to 6. Yes. If you want to calculate 5 factorial, that would be 5 into 4 into 3 into 2 into 1, this will be 120. Hope everyone understand what factorial is, right? So if I ask you to write the code for factorial, so we will get one input. Let's say input is 5. Then the output, our answer should be this 120. This 120 should be our answer. So how can we calculate factorial? What concept we can use here? Opening a chat for a bit. What we can do to solve this problem of factorial? Yes, we can use loops. Perfect. We can use loops. Great. So we have to find factorial, right? So how we can write the code for this? We can create a variable int answer equal to 1, right? And we can write a loop till that point, int I equal to 1, I less than equal to n, I plus plus. And here we can do answer star equal to I. And at last we can print the answer. Obviously we have to take this n input first, right? So we'll write all the boilerplate code, that int main, and then we'll take input of this n, int n, cnn, and then we will solve for this factorial, right? Okay, let's do a small try run for n equal to 5 maybe. So if the input is n equal to 5, we start our answer with 1. Answer is initially 1. Okay, I is 1. I is 1. So is 1 less than equal to 5? Yes. We enter the loop, we say multiply answer with I. What is I right now? I is 1. So 1 into 1 will be 1 only. It is 1 only. Perfect. Then I becomes 2. I becomes 2. Is 2 less than equal to 5? Yes. Multiply the answer with 2. It becomes 1 into 2, that is 2. Then I becomes 3. Is 3 less than equal to 5? Yes. We multiply answer with 3 now. Answer becomes 6. I becomes 4. Is 4 less than equal to 5? Yes. Multiply answer with 4. It becomes 24. I becomes 5. Is 5 less than equal to 5? Multiply this 24 with 5. This becomes 120. I becomes 6. Is 6 less than equal to 5? No. We come out of the loop and print this answer. And print this answer. I hope everyone understands that how we can find n factorial. Very easy to find n factorial. Yes or no? Yes. Great. Now we know how to find n factorial. There is one more concept of binomial coefficient. If you are prepared for JEE or studied maths in 11th, 12th, there is a concept of binomial coefficient, that is this NCR. How is this NCR defined? NCR is defined by this formula. So you will get two inputs. So in the input, you will get two things. One is this n and one is r. For example, n is equal to 5 and r is equal to 2. So if you have to find 5 C2, this will be equal to n factorial, that is 5 here. So 5 factorial divided by 2 factorial into n minus r is what? 5 minus 2, that is 3 factorial, right? So we have to solve this thing. This will be equal to, this was 120, this is 2, this is 6. So this will be come out to be, so 6 to 12, this will come out to be 10. Right? Hope everyone understands what is the binomial coefficient. Just apply this formula and we can find NCR. Okay.
Okay, so n is 5, r is 2.
To find n factorial, there is one more concept of binomial coefficient. If you are prepared for JEE or studied maths in 11th, 12th, there is a concept of binomial coefficient, that is this NCR. How is this NCR defined? NCR is defined by this formula. So you will get two inputs. So in the input, you will get two things. One is this n and one is r. For example, n is equal to 5 and r is equal to 2. So if you have to find 5C2, this will be equal to n factorial, that is 5 here. So 5 factorial divided by 2 factorial into n minus r is what? 5 minus 2, that is 3 factorial, right? So we have to solve this thing. This will be equal to, this was 120, this is 2, this is 6. So this will be come out to be, so 6 to 12, this will come out to be 10. Right? Hope everyone understands what is the binomial coefficient. Just apply this formula and we can find NCR. Okay. Now to find NCR, we can use this formula. If we have to write the code, let's say we have to write the code, we are getting two numbers, input n and r. This is the input, and the result we have to print is NCR, that is equal to n factorial divided by r factorial upon n minus r factorial. Yes. Let's say we write the code for this. We already know how we can find factorials. Yes, you already know the code for this. So how we can solve this? We will take this time two inputs, int n and r, right? So we'll do c in n and r from here, right? Now we need to find these three terms. We need to find n factorial, we need to find r factorial, and we need to find n minus r factorial, and then we will multiply these two and divide it by n factorial. Yes. So how do we find n factorial? We can use that same loop. We can use this same loop. To find, yes. So how do we find n factorial? We can use that same loop. We can use this same loop to find n factorial. So let's call this thing n factorial. We initialize it with 1 and find our answer here. Okay. So this loop will find this term, that is n factorial. Now we want r factorial as well. So we'll write this again. We'll write this again, but for r. So we will need a loop that will run for how many times? We need a loop now that will run. Maybe let's write it here itself. That will run for r number of times. This will be r factorial. Correct. So this will give us r factorial. Now we want one more term, that is n minus r factorial. Correct. So we'll again need a loop for that. Let's call it n r factorial. And this time the loop will go till which point? What should come here? We should have n minus r here. N minus r here. Yes. So as you can see, we need to find these three terms. That's how we can find it. One loop for n factorial, one loop for r factorial, and one loop for n minus r factorial. Okay. Once we have these three values, once we have this r factorial, we have n minus r factorial, this n r factorial, and this n factorial, we can easily find our answer. We can say C out n factorial divided by r factorial into n minus r factorial. That's how we can solve this problem. Is this code making sense to everyone? Give a yes or no. Is everyone able to understand this? That how we can find this NCR? Yes. Cool. Now, can you guys see a problem here? Can you guys see a problem here? Don't you think we are rewriting the same code again and again? This piece of code, this piece of code, and this piece of code as well. Yes. Factorial. Logically, it is perfect. Not itself a good practice. Let's say that if I give some input in this box, some code is executed, and after that, I get the result of n factorial. Yes. For example, if I give here n equal to 5, if let's say again, yes, writing function, we can rewrite this in a function. Functions are basically some set of statements that we write only once, and we can reuse it multiple times. As you can see here, we have some input. Okay, there is a function which does some job for us, which runs some code and gives us an output. Now we can call this function as many times as we want, right? This will make our code much more cleaner if it will be part of code correctly. But you miss, let's say, यहाँ पर less than equal to wrote यहाँ पर less than, then your output will be wrong, even though your above part is correct. So it will become a little hard to debug, right? So it's better that you write it only once and reuse as per your want, right? This is the high level concept of functions. Okay. Now let's see how we can write a function. So this is a syntax for a function, right? So here we have something return type, the function name, some parameters, a return value. Do not get overwhelmed. It might look a little scary at the very first, but it's very easy. Okay. So or a function name. So what is real? An integer function will return. Now what is function n is for still here function. यहाँ पे answer. What if r factorial loop factorial into this n minus r? Let's check for 5c2. Now the same logic you wrote it thrice. So we'll say int answer from here. Yes. Use this equal to the value of, so that the value r with value n minus r. Yes. And we can print this answer at the we have written this logic only once and code work. Yes. Let's do two numbers a and b यहाँ पर, and we'll get a plus b in the result. If we wanted to find some a also some of it, so what do we return? If we want to find some of 6, 5, then a that we return. If we were to add three numbers, that int of it does we want, this will go back from int of, okay, and now goes back to the main. Okay, numbers are as soon as go back in, so keep on, and we will get this output. So we just discussed print 1 to n. So here we have void. Void means it doesn't return anything, it just prints a square. It says maybe of 10 you can print one more square. So we got prints of the amount. How? Yes. I hope this makes sense to everyone, that how we can use functions, how this will make our lives easy and simple. While this print square function receives inputs. Parameters. What were parameters? Parameters is I just come to argue more parameters must match, right? So means instant type is must, that is returned in this types from everything. Tutor and see there. Right now,
Yes,
there
what I
for
think
this return
is
statement.
let's start with the time and space complexity, because it is very basic. Functions, then we have arrays, then we have strings that we already learned in JavaScript. Sorting, searching basics, yeah, I can start with it. Sorting and searching basics.
Hello. Good evening, everyone. Am I properly audible and visible? Yes. Great. Yes. So guys, today we'll be learning about sorting and searching. We'll just do the basics today, and whatever is required to learn about sorting and searching. So let me share my screen. Yes. All right. Can you guys see my screen? Yes or no? Yes? Great. So now I'm just turning off the chat. I'll open it again when I ask you some questions. Alright, so let's start with the first topic today, that is searching. Now guys, what is searching? Searching means to look for something, to find something, right? Searching means to look for something or to find something. Let's start with a very simple example. Let's say we're given an array. The array looks something like this, that we have 1, 10, 7, 6, 4, 3, 2, 11, 9, 15, 17, 28. Okay. So we have this random array with us. Let's remove one from the beginning. Let's take this array. Okay. Let's say we're given an array. Along with this array, we're given a target value. Let's say target here is 9. So if I ask you, you have to search whether this target, that is 9, is present in this array or not. So what will be your answer? Is this target element 9 present in your array? Yes or no? You can just give a big thumbs up if you can see 9 is there. If it is not present, you can give a thumbs down. Can you guys see 9 in this array somewhere? Yes, 9 is clearly visible here, right? Okay. So if I ask you to write the code for this, what will you do? What will be your approach? So you'll say, sir, what I'll do is I'll start looking from the very first element of the array. Yes. You will see, acha, is this element matching with the target or not? So these two are not equal. So you will go to the next element. You will go to the, I'll just make this like this. That. Let's say we are here, right? Searching here. You will say this is not matching the target element. Okay, so we'll check here at this point. Is this equal to 9? No, it is not 9. So go forward. Is this 9? No, it is not 9. Check ahead. Is it 9? No. Check ahead. Is it 9? No. Check ahead. 9. No. No. Yes. It matches the target element. So we'll say this 9 is present in this array. So what will you do? You will write a for loop over this array. Compare with every element one by one, that is it equal to the target or not. If it is equal, you will say, acha, flag value will make it true, and you can come out of the array and say your answer is yes, that this target element exists in the array. So what we can do is we can maintain a boolean flag. Let's say equal to false initially. Okay. Then we can write a for loop over the array. Then I plus plus. We'll just say if this a of I is equal to target, that means we have figured out that this element exists in the array. So we'll say flag is true, and you can come out of this array, come out of this loop, sorry. And once you're out of this loop, based on the flag value, you can say whether the element was there in the array or not. So if flag was true, that means we were able to find the element in the array. We can just print yes, it exists. Otherwise, we can say this doesn't exist. I hope this code makes sense to everyone. This approach makes sense to everyone. That how we're searching for an element in the entire array one by one, going through each and every element. Yes. Great. Okay. Guys, can you tell me, let's say, currently this array is in any random order. Okay. Now, what if I sort this array? What do I mean by sorting? Sorting means I will arrange this data, let's say, in ascending order. So if I arrange the data in ascending order, this array will look like first element will be 2, then it will be 3, then it will be 4, 6, okay, 7, then next will be 9, then 10, then 11, 15, 17, 20. Okay. Now, again, the same question. The array is sorted. And again, we want to find the 9. Again, we want to check whether 9 is there in this array or not. Okay. This can we again apply this same approach to check whether 9 is present in the array or not? What do you think? Can we again apply this same approach to check whether 9 is there in the array or not? Yes, we can do that. Again, we can start from the beginning. We can start from the very first point. We'll compare. Does this 2 matches with 9? No, it doesn't match. Does it match? No. Does it match? No. Go forward. It matches? No. It matches? No. It matches? Yes. Yes. So it matches with the target element. So we can say we are able to find it and break. So this algorithm will work in, this idea will work in the sorted array as well. There's this idea in which we're checking every element one by one. This thing is known as linear search. This entire idea is known as linear search. This thing is known as linear search. That linearly we are searching over the array one by one. Okay. Now, if we know the data is sorted, if we know the data is sorted, the data is sorted in ascending order. Now, can we search little faster in that array? What do you guys think? Let's say if I was searching for maybe 14. So what we can do is we'll start from the beginning itself. Okay. Now we'll compare this 2 with 14. They don't match. Go forward. They don't match. Go forward. 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 Now, guys, you reach at this 15, and you were still not able to find 14. Now tell me, do we even need to continue searching in this array? I already know the data is sorted in ascending order. So can we directly stop here and say, if we are not able to find 14 up till this point, we will not be able to find 14 ahead also. Why? Because the data is sorted in ascending order. We got a bigger element here, and we cannot find 14 ahead of this. Does this make sense to everyone? That if the data is sorted, we can break early. If the data is sorted, we can break early as well. This makes sense to everyone? Yes. Okay. So in the same code, what we can add? In the same code, what we can add? We'll say if target it matches, break it. Okay, we can just copy the same code. We can have one more check here, that if a of I has become more than the target, then we know because data is sorted, we can break. Data is sorted, we won't find the target now ahead in the remaining part of the array, so we can break early as well. We can break early as well. Okay. Now this can make our idea little faster, but now if you think, guys, in the worst case scenario, let's say if target was given as 29, if target was 29, still we have to go up till last of the array in the worst case scenario. The our loop will start from first place and will go till the last. This early break strategy won't be very helpful in that case, right? Even if data was sorted, here we cannot break early because we are going linearly one by one. We're going linearly one by one. Okay. All right. Now, can we make this even faster? Can we exploit this fact the data is sorted and try to find the target element little faster? Let's see what we can do. Now, this brings us to the concept of binary search. Binary search is an extremely powerful technique and it works only on the sorted data. Sorted data, it means we can apply binary search. Okay, let's add few more elements here. Let's say I add here 35, 40, 60, 70, 65, 69. Okay. Now we have this big of an array. Okay, let's also give them indices. Let's write indices also in front of them. So this element is at index 0, index 1, index 2, index 3, 4, 5, 6, index 7, index 8, index 9, index 10, 11, 12, 13, 14, 15, and 16. Okay, so we have given them the indices, required indices. Okay, now let's say we want to search. Just zoom on this a bit. Okay, let's say the target element we're looking for is, for example, 60 in this case. We are searching for 60. Okay, we are searching for 60. Now, in the earlier strategy, what we were doing was that we're checking from the first element. We were starting the loop from here and iterating over this array one by one like this. First, we start at 2, then go to 3, then 4, 6, 7, and so on. In binary search, instead of starting from the left, what we can do, start from the middle element. Start from the middle element. All right. So in this list, we are currently, the array is the complete part 0 to 16. If I ask you, guys, what is the middle element here in this array? What is the middle element here? So currently, our array starts from here. Array starts from here. Maybe I'll just do it. Array starts from here. Okay. I'll call this the L point, the starting point. Array starts from here. Okay. And array ends at this point, that is R. Okay. So currently our L, we have this L variable. We have this R, right? L currently is at 0, at this index 0. R is at index 16. So now if you want to find the middle element, mid will be equal to what? Yes, it will be equal to the average of these two, that is L plus R divided by 2. So in this case, L is at 0, R is at 16. Mid will be at 0 plus 16 by 2, that is 8. So mid will be somewhat here. Mid will be somewhat here, right? Okay. Now, instead of comparing the two, 7 or anything else, let's just compare this target element with this middle element. Mid is at 8. Mid is 8. What is there at index 8? It is 15. It is 15. Guys, is this 15 equal to target? Does this match this target? No, it doesn't match this. But can we predict here? We are at this 15. Okay, data is sorted. Now, can you tell me if 60 exists in this array, where it can exist? Can it exist in the left part? Is it possible that we find 60 on the left hand side? Yes or no? Can we find 60 here on the left hand side? Yes or no? Can we find 60 on the left hand side? Say down if you think the answer is no. Can we find 60 here on the left hand side? I think the answer is no. We cannot find 60 here. Why? Because data is sorted. So 60 is bigger. 60 can only exist in this part. 60 can only exist in this right part. So what we can say at this point, we can discard this search space and we should only focus upon this remaining array. Right? Okay. Now this L is at 9. This L is at index 9. R is still at index 16. Now we again find the middle element.
Right. As data is sorted, if middle element is not target, then take middle element as start point. If target is greater than middle element, and endpoint if target is less than middle element. Discard the rest.
element here. So now mid will be equal to 9 plus 16 by 2. That is 25 by 2. That will be equal to 12.5. But we're only concerned about the integer value, so we'll just write 12. Okay. So mid will be here. Mid will be here. Now again compare the middle element with this target. Now do they both match? Is 40 equal to 60? No, they don't match. But can we say, acha, because data is sorted, can we say 60 cannot lie on this left part? If it exists, it can only lie in the right hand side of this. So again, we can do the same thing. Discard this part of the array and let's just focus upon this part. Now L is at index 13, R is at index 16. All right, let's again find the middle element. Middle will be at 13 plus 16 by 2. This will be 29 by 2 equal to 14.5. We just want the integer value, so just 14. Okay. So mid will land somewhat here. Mid will land somewhat here at 40. We again compare this middle element with the target. Do they both match? Is this 65 equal to this 60? No. But can we say, because data is sorted, 60 can only exist in the left hand side, right? So what we can do, we can just discard this entire part. And in that case, the search space is just this single element now. L and R now are both at this 13. L is there at 13. R is also now at 13. So 13 plus 13 divided by 2. Mid will also be at 30. Mid is now also at 30. Now we compare this 60 with the target. Do they both match? Yes, they match. Hence we say we were able to find 60 in this array. Now if you see, it just took us 4 steps. It just took us 4 steps to locate 60 in this array because the data was sorted. This is much faster than the previous one. The previous strategy in which we were looking for the element one by one. Okay. Does this idea make sense to everyone? That every time we go to middle, every time we go to a middle element, we compare with this middle element. We compare with this middle element. Okay. We check if this A of mid, the element at this middle index, if it matches the target, then boom, we have found the answer. We can say flag is true and break. Great. Else if we say if A of mid is more than target, as if A of mid is more than target, in that case, in which side we should search? If it is bigger, we want to find a smaller value, so search in the left hand side. So search in the left hand side. Otherwise, we should search in the right hand side. Is this idea somewhat making sense to everyone? I'll just open the chat to see if this idea is clear or not. We'll do some more examples, but is the intuition making sense? Yes. Okay. Guys, do not worry about the time complexity. We'll discuss about that in the later lectures, in the future lectures. So do not worry about that. Okay. So now what we're doing is, we were saying the data was sorted. Let's take one more example. I'll just copy this array again. Now let's see an example where the target element does not exist in the array. Okay. In that case, let's see what happens. Let's say target is, for example, 52. Target is 52. Okay. So initially, L will be at this index 0. L will be at index 0. R will be here at the last index. I'll copy the indices as well. We need them as well. So index 1 will be here, 3 here, 5 here, 14 and 50. Okay, great. Let's bring this table again as well. We will need this. So initially, L is at 0, R is at 16 at the corners of the array. Okay. So first we find the mid index. Mid will be 0 plus 16 by 2, that is 8. So mid will be somewhat here. Mid will be here. All right. Now let's compare the target element with this 15. Do they both match? No, they don't match. But because the data is sorted, can we say if 52 exists, it can only exist in the right hand part. 52 cannot be there in this left hand side because it is bigger, right? So we can discard this entire thing. No need to search here. No need to search here. Okay. And in this, after this case, where this L should go? Now this L should go to mid plus 1 at this point. Okay. Now what we are doing is we have changed L to mid plus 1. Now we'll search in this part. Okay. Now L is at index 9. R is still at index 16. Again, find the middle element. Middle will be at 9 plus 16 divided by 2. That is 25 by 2. That will be 12.5. We just need the integer value, so 12 will be 5. So this will be the middle index. Okay. Now compare this 52 with 40. Do they both match? No, they don't match. Okay. But can this 40 still help us to figure out where this 52 will lie? Yes. 52 is bigger, so it can only exist in the right hand part. So we can again discard this left hand side. Again discard this left hand side. Okay. Again, what will happen? This L will now move to mid plus 1. L will again be equal to mid plus 1. Okay. Now L starts. Now L is at index 13. R is still at 16. Okay. Find the middle element. Middle will be at 13 plus 16 divided by 2, 29 by 2. So 14.5, we just need the integer value, so 40. So middle will now be here at 40. Now compare 52 with 65. Do they both match? No, they don't match. Achha. Now if 52 exists, where it can lie? Can it lie on the right hand side? No, it can only lie in the left hand side because it is smaller. So what we'll do? We'll discard this entire part. We'll discard this entire part. And now this right will move to this place. So in this case, what has happened? R is now equal to mid minus 1. R has now is equal to mid minus 1. L is at 13. R is also at 13. Middle will be 13 plus 13 divided by 2. This will be 26 by 2, 13 only. Okay. middle also be here. Okay. Now compare this target with this middle element, that is 60. Do they both match? No.
ओके गाइस, तो बाइनरी सर्च कुछ ऐसा होगा। हमारे पास सॉर्टेड एरे इनपुट होगा, टारगेट इनपुट होगा। उसके बाद हम एक वेरिएबल डिफाइन करेंगे लेट स्टार्ट, दैट इज 0, और एंड जो होगा हमारा सॉर्टेड एरे का लेंथ -1 होगा। और अब हमारा यहाँ पे लूप जो लगेगा वो लगेगा स्टार्ट इज लेस देन इक्वल टू एंड। जब तक स्टार्ट एंड से छोटा या फिर इक्वल है तब तक ये लूप चलेगा। जैसे स्टार्ट एंड से बढ़ जाएगा तो लूप नहीं चलेगा। तो उसमें हम मिडल एलिमेंट डिफाइन कर रहे हैं जो कि होगा स्टार्ट प्लस एंड बाय 2। और जैसे कि हमें सिर्फ इंटीजर चाहिए तो मैथ डॉट फ्लोर यूज़ किया है। और जब सॉर्टेड एरे ऑफ मिडल, हाँ ये तो इंडेक्स है, सॉर्टेड एरे ऑफ मिडल इज इक्वल टू टारगेट, then return middle because it is the target, and if not then check if sorted array of middle is less than target, then start will be middle plus 1। क्योंकि जब हमारा टारगेट बड़ा होगा मिडल से तब हमारा मिडल बनेगा स्टार्ट। मिडल का आगे का, अच्छा मिडल के आगे का एलिमेंट बनेगा स्टार्ट। और नहीं तो हमारा एंड क्या बनेगा, हमारा स्टार्ट बनेगा मिडल का आगे का एलिमेंट, आगे का इंडेक्स सॉरी। और हमारा एंड क्या बनेगा, मिडल का पीछे वाला इंडेक्स। और अगर हमें नहीं मिला वाइल लूप में तो हम रिटर्न कर देंगे -1। तो सिंपली हम इसको कर देंगे। तो देखते हैं हम इसको कोड करके D1 binary search. ओके, तो अभी हमें क्या करना है, पहले तो एक फंक्शन डिफाइन करना है। जेरिएट की आदत हो गई कैपिटल लेटर। बाइनरी सर्च इनपुट लेगा हमारा सॉर्टेड एरे, और क्या होगा हमारा टारगेट। ओके, हम अभी नीचे इसको कॉल करते हैं बाइनरी सर्च फंक्शन को। पहले होगा हमारा इनपुट एरे, इसमें होगा हमारा सॉर्टेड एरे 7 6 8 9 10 15 16 14 12। ओह नहीं 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 नहीं, 15 16 ये सॉर्टेड है ना, 18 19। तो हमने कॉल कर दिया, और हमें कॉल करना है टारगेट। हमारा टारगेट इसमें होगा 15, नहीं 15 नहीं करते, हम करते हैं 6। टारगेट हमारा 6 होगा। ओके ओके, तो फिर अभी हमें क्या करना है, हमें पहले तो स्टार्ट इंडेक्स डिफाइन करना है। स्टार्ट होगा हमारा 0, और हमारा एंड होगा, अरे यार, हमारा एंड होगा सॉर्टेड एरे लेंथ ऑफ सॉर्टेड एरे, सॉर्टेड एरे डॉट लेंथ -1। हमारा इनिशियल स्टार्ट और एंड इंडेक्स तो हो गया है। अब हम रन करेंगे एक लूप, हम रन करेंगे वाइल लूप। जब तक हमारा स्टार्ट इंडेक्स जो है वो लेस देन या फिर इक्वल टू एंड है, तब तक हमारा लूप चलेगा। और अगर हमारा लूप में हमें एलिमेंट नहीं मिला तो लूप से बाहर आएंगे और रिटर्न कर देंगे -1, मतलब हमें एलिमेंट नहीं मिला। और अंदर क्या होगा, ओके तो अंदर क्या होगा अभी, कंडीशन पहले हम मेल को डिफाइन करेंगे ना, लेट मिडल, जो कि हमारा मिडल एलिमेंट होगा, उसको हमें ये करना है, मैन डॉट फ्लो करना है, क्योंकि हमें वो इंटीजर चाहिए। तो वो होगा हमारा स्टार्ट प्लस एंड, डिवाइड बाय 2। तो हमारे यहाँ पे मिडिल एलिमेंट हमें मिल गया। तो हम क्या करेंगे कि चेक करेंगे इफ द मिडिल एलिमेंट दैट वी गॉट, इफ द मिडल, अरे कलर स्कीम अच्छा नहीं इसका, इक्वल टू टारगेट, देन हम सिंपली रिटर्न करेंगे हमारा मिडल, क्योंकि वही हमारा टारगेट मिल गया, तो वही इंडेक्स हम रिटर्न करेंगे। और अगर ऐसा नहीं होगा तो इफ टारगेट नहीं होगा तो हम क्या करेंगे, हमारा सॉर्टेड एरे में जो हमारा ये मिडल है जो मिडिल एलिमेंट है उसको चेक करेंगे। अगर वो मतलब हमारा टारगेट अगर बड़ा होगा तो ऑब्वियसली हमें राइट साइड एलिमेंट मिलेंगे, क्योंकि सॉर्टेड एरे है ना। तो सॉर्टेड एरे ऑफ मिडल, जो मिडल हमारा है वो छोटा होगा टारगेट से। देन हमारा क्या होगा, अगर सॉर्टेड एरे ऑफ मिरर इज लेस देन टारगेट, देन हमारा जो स्टार्ट होगा, एंड तो हमारा वैसे ही रहेगा क्योंकि राइट साइड जाना ना, तो हमारा स्टार्ट खाली चेंज होगा। स्टार्ट होगा हमारा मिडल +1, क्योंकि मिडल तो हमने अभी चेक किया तो वो तो नहीं है। या तो फिर अभी एल्स में क्या होगा, तो मतलब हमारा मिडल बड़ा है टारगेट से, तो लेफ्ट साइड हमारा टारगेट होगा। तो इसकी वजह से हमारा एंड जो होगा मिडल की तरफ आएगा। तो एंड हमारा होगा मिडल -1, क्योंकि हमें लेफ्ट साइड जाना है। मिडल -1 हो गया। इतना ही था शायद, मुझे लगता है। हम्म, तो हमने स्टार्ट और एंड इसको सही से किया। तो इसको रन करके देखते हैं। CD day1 नोड बाइनरी। अब हमने रिटर्न ही नहीं किया ना हमने मतलब कंसोल ही नहीं किया ना। कंसोल लॉग, हमारा -1 आ गया। ऐसा क्यों हुआ? यहाँ तो 6 इसको मिलना चाहिए था। कुछ हमने गड़बड़ कर दी है क्या? हमारा स्टार्ट इंडेक्स 0 है। हमारा सॉर्टेड एंड भी सही है। स्टार्ट एंड कंडीशन भी सही है। और हमारा मिडल भी सही है। सही। अरे भाई, वहाँ मिडल तो इंडेक्स है ना, तो सेट सॉर्टेड एरिया ऑफ मिडल। ओके दैट्स इट। या मिल गया। तो हमारा 3 प्रिंट होगा, क्योंकि 0 1 2 3 ये हमारा इंडेक्स है, राइट। तो अगर मैं इसमें एक ऐसा नंबर डाल दूँ जो एग्जिस्ट नहीं करता, तो हमारा -1 रिटर्न होगा। या -1 रिटर्न हो गया। दिस इज तो हम लीनियर सर्च भी बना ही देते हैं। लीनियर सर्च डॉट जेएस, उसमें हमारा फंक्शन होगा कॉन्स्ट लीनियर सर्च। इसमें हमें भी इसमें भी सॉर्टेड एरे मिलेगा, और दूसरा हमें मिलेगा टारगेट। और नीचे हम कंसोल डॉट लॉग, कंसोल लॉग हमारा होगा लीनियर सर्च फंक्शन को कॉल। इसमें जाएगा एक एरे सॉरी गाइस विक्स की गोली लो, खिंच खिंच दूर करो। ओके। तो अभी हमारा क्या हुआ है, लीनियर सर्च हमने यहाँ पे लिया। हाँ, तो अभी यहाँ पे सॉर्टेड एरे नहीं होगा तभी चलेगा, क्योंकि हम लीनियर सर्च कर रहे हैं, 1 बाय 1 कर रहे हैं। तो कैसे भी हो सकता है। डुप्लीकेट एलिमेंट मत डालो। ओके, और हमें फाइंड आउट करना है 7। तो इसमें हमारा सिंपली फॉर लूप होगा, फॉर लेट आई इज इक्वल टू 0, आई विल बी लेस देन सॉर्टेड एरे डॉट लेंथ और हमारा होगा आई प्लस प्लस। ओके, तो हमने लूप क्रिएट कर लिया जो सॉर्टेड एरे को इटरेट करेगा। अब इसमें हमें क्या करना है, टारगेट को फाइंड आउट करना है। सो इफ इफ क्या होगा, हमारा सॉर्टेड एरे ऑफ आई इज इक्वल टू टारगेट, देन तुम रिटर्न कर दो आई को, सिंपल राइट। सॉर्टेड एरे ऑफ आई इज टारगेट, देन रिटर्न कर दो आई। और अगर फॉर लूप में नहीं मिला तो रिटर्न कर दो -1। दैट्स इट। इसको रन करते हैं। 3 मिल गया। मैं इसमें अभी 10 डालता हूँ तो इसका होगा 6 हो गया। 0 1 2 3 4 5 6 राइट। अब यहाँ पे मैं 11 डालता हूँ जो इसमें है नहीं, तो ये -1 रिटर्न करना चाहिए। तो मैंने यहाँ पे गैस 11 डाला है और ये कुछ भी रिटर्न नहीं कर रहा और स्टक हो गया है। Why it is like this? ओके ओके, तो हमने ये नहीं किया ना रिटर्न, इसको ब्रेक नहीं किया। ब्रेक तो ऑटोमेटिक होना चाहिए ना जब हमारा, अरे यार ये किसने डाला इधर। आई शुड बी लेस देन। अब हो गया। यहाँ पे कुछ तो टाइप एरर था और मैंने यहाँ से मिटा दिया था। अब देखो -1 आ रहा है। अगर मैं यहाँ पे डालता हूँ 18 -1। Okay, so this is linear search and this is binary search. Both we added. Let's move ahead.
They don't match. They don't match. Okay. Now, if 52 want to exist, it can only exist in the left hand side, on the left hand side. But guys, now do we have something on the left? No, there is nothing on the left. So we'll just discard this and stop our search. And just stop our search. Okay. Now, is this example creative even? In this case, the last element was also not equal, so we were not able to find the target element. So one more video, let's see if I'm able to find it. Guys, are you able to see this tab? This screen of YouTube? Let me just in the chat. Yes. Okay. Great. So, guys, in this video, he is trying to find a word denture. Denture in the dictionary. Okay. He has a dictionary with him in which the words are arranged in ascending order. Right? He's trying to find denture. So let's see what strategy he uses to find that word. So the first word in this book is accountants, and the last word is woodworkers. Okay. First word is accountants, last word is woodworkers, and the words are arranged in ascending order. So let's see what he does. What he does. So now, if we open the middle page, we have lawyers in that. Okay. So we have lawyers. We are looking for this word denture. Okay. Now let's see what he does. So denture exists. It can only exist in the left hand side. Right part is of no use. So let's see what it does now. So we don't need that. I will just search in this remaining part. Again, what to do in this remaining part? Accountants, lawyers. Again find the middle. Now we land at doors. Okay. So guys, if danger want to exist in this dictionary, where it will exist? Where it can exist? Only on the left hand side. So again, can we say right hand side is of no use? Okay, the right side is of no use. Now you can see we just did two comparisons, and book size was that much. Now book is just this, right? Accountant is the first word now, and last is now doors. Okay. Again, the strategy would be to check at the middle point. Middle is now bridle. Okay. Looking for dentures. Now guys, which part is of no use? I think left part is of no use. So again, we destroy that. Only this matrix. Can you see now how this strategy is how faster? Again, find the middle. Now it starts from bridle to door. I think we found the dentures in the middle part. Okay. But is this strategy clear to everyone that what we were doing? Yes. Right. So the if let's say dictionary was of 1,000 pages, we were looking into 1,000 pages one by one, one by one. Instead of doing that, what we did, we were going to the middle. We were saying, "Acha, it will exist on the left or right side." We will just focus on that side and destroy the remaining part. Okay. All right. So let's see how we can write the code for this. Okay. So first we create one variable that is L. L will be at 0. R will be at the last index that is n minus 1. Okay. Okay. Then we write a while loop. Now what condition will come here in the while loop? We'll decide that. We'll decide that in a moment. Okay. At every step, do what? Find the middle. Middle will be at L plus R by 2. Okay. Now we check if A of mid matches the target element. If it matches the target element, we can say we are able to find it. So we can make our flag equal to true and break from the array. So let's also maintain this flag. It's initially false. Okay. Great. Acha. Else if this A of mid is more than target, means if the middle element is more than target, where we should search? We should search in the left hand side because we want to reduce this value. Otherwise, search on the right hand side. Now, how we can do that? How we can search in the left hand side? Let's see here. What we're doing is we have one L variable, one R variable. We find the middle element. Okay. Okay. Now, if it is equal, then great, we found the answer. Otherwise, if it is more than what we're looking for, then we have to search in which part. If this value is more than target, for example, we are looking for 52 and this value is 60. In this case, where we should search? We should search in the left hand side. It means this part. That means we should move this R to mid minus 1. We should move this R to mid minus 1. Okay. This should be a new search space. So what we do here? We update R to mid minus 1. We are searching in the left hand side. Okay. Let's look at this case. What if we were looking for 52 and this value was smaller? Let's say it was 40. Now in this case, where we should search? In this case, we should search in the right hand side. In the right hand side. So what will happen? This L will move at this point, at mid plus 1. At mid plus 1. Is everyone understand this code? That if it matches, flag is true, break. If the current element, if the middle element is more than the target, search on the left hand side. That means move this R to mid minus 1. Great. If it was smaller, then you have to search here. In that case, move this L to mid plus 1. And repeat the same process here. Repeat the same process here. Okay. Now let's try to figure out what will come here. What will come here? Like if you just make a small guess, we just want key search space should always exist. So it should be L less than equal to R. L should always be less than equal to R. Okay. We'll prove it also why this should be true, L less than equal to R. Let's look at a very small example. Okay. Let's say we have an array like this 1, 7, 8, 11, 15. Okay. And here let's say we're looking for target. Target is 9. Target is 9. Okay. So initially L will be here at this point. R will be here. Index will be, this is index 0, index 1, index 2, index 3, index 4. Okay, great. Now, if you want to find the mid will be 0 plus 4 by 2. So it will land here, somewhat here. Okay. Now we'll check. Let's see through this code. Mid will be at this 2. Is it equal? No, it is not equal. Is it bigger? No, it is not bigger. So come in the else case. Now we should search in the right hand side. So move L to mid plus 1. To search in this part. That means this part has been discarded. Amazing. Okay. Now again you find mid. Mid will be 3 plus 4 by 2. That is 7 by 2. Floor value will be 3. So you land here. Mid is here. Okay. Now you compare. Is this 11 equal to 9? No. Is this 11 more than 9? Yes. So search in the left hand side. So for that, make R equal to mid minus 1. So mid is here. R will be here. Now if you see, these two pointers, L and R, have crossed each other. Yes. So at this moment, we can stop. At this moment, we can stop saying key. We have checked in the entire array and we were not able to find this line. Is this logic clear to everyone? that how binary search is being applied on the sorted data, on the sorted arrays. Yes. Saurabh has asked, sir, why L less than equal to R? Why not L less than R? So because it can happen, if you remember this example, in which we were able to find 60 in the last iteration. Yes. So in this case, L was at 13, R was at 13. Here also we need to check the last element. Okay. So it should always be L less than equal to R, because at last it is possible only one single element exists. Only one single element exists. Okay. I hope this makes sense to everyone, that how this binary search code is working. Yes. And once this loop is completed, at the end we can just say, if flag was true, we can print yes. So we were able to find the element. Otherwise, we were not able to find the element. That's it. So now we have applied this logic on an integer array, in which we had an array of integers. But there's the same logic. Can the same logic can work with strings also? If I give you some strings in sorted fashion, like a dictionary, if I give you a lot of words in sorted fashion, can this strategy still work there? Can this strategy of going to middle and then discarding one side completely and repeating the same process until you find that word, will it work there as well? Yes, we just saw that in the dictionary example, that how this person was able to find a word in minimal steps. Every step he go to the middle element, compares with the required word. If it matches, great. If it doesn't, he decides, acha, should I search in left or right? One of the part will be destroyed. We'll focus on the remaining part only. So in the beginning, he started with this big book, but when he reached towards the end, only 1 or 2 pages were left. That's the power of binary search. That's the power of binary search. Okay. So with this knowledge, you would be able to solve the first 3 assignment problems. Okay. So I hope everyone solves them before the next class. So this completes our basic searching part. That what was searching? Searching is nothing but to look for something or to find something. If the data is in any random order, if data is not sorted, in that case, what we should apply? If data is in random order, we should apply linear search, because it can happen in the worst case. What we are looking for can be there at the end, can be somewhere in the middle, can be towards the end, towards the left. It can be anywhere, right? We should search at each and every point. But if the data is sorted, we can leverage that fact and use binary search there to find the answer in minimal steps. This was the idea of binary search. We'll do advanced binary search also when we start with the DSA phase. So this is like the last class of phase 1, where we were learning the language and the basics. Okay. So phase 1. So if I'm able to find, let's say, the syllabus part, just open the syllabus. Guys, can you see this tab, the syllabus tab? Yes. So our phase 1 gets completed today. That is introduction, low file printing, arrays, 2D arrays, string sorting, right? Now, from the next week, we'll start with pointers, parser value, parser reference. This is more about the DSA part. This is the memory management, time and space, set and maps. Now the real DSA starts after this. Okay. So people who are waiting for the DSA to start, you can join in from the next classes. All right. So now we're done with the searching basics. Let's move on to the next part. Next part, guys, is sorting. Next part is sorting. Guys, if I ask you, what do you guys understand when I say sorting? What is sorting? Sorting means to rearrange data in a specific order. In a specific order. Okay. It can be ascending order, it can be descending order, right? It can be ascending, it can be descending as well. All right.
Yeah, so sorting means rearrange in specific order. It can be ascending or descending.
Now, for example, if I give you an array, let's say array is somewhat like this: 1, 2, 4, 8, 10, 20, 30, 40. Guys, if I ask you, is this array sorted? क्या array sorted है? Yes, the array is sorted. This array is sorted in ascending order. In ascending order. Correct. Let's see one more array. Here it is 11. Make it 100 maybe. Now guys, if I ask you, is this array sorted? Is this array sorted? Yes, this array is also sorted, but in descending order. But in descending order. Okay. Now our task would be that we will be given an array. We will be given an array like this. Any random order. Let's say 11 is there, then 2, 14, 18, 20, 27, maybe 3, and 40. And here our goal is to sort this array. Goal is to sort this array in ascending order. In ascending order. Goal is to sort this in ascending order. And we are not allowed to use any inbuilt function. We cannot use any inbuilt function for this. Okay. So there are a lot of algorithms, there are a lot of strategies to sort an array. Okay. There is, let's start the simplest ones. Simplest is selection sort. We have bubble sort. We have insertion sort. Then we have merge sort, heap sort, and quick sort. So these last three ones are a little advanced. This will be covered in the DSA section in the future classes. Today, our primary goal would be to learn the basic sorting algorithms. That is the top three, the first three algorithms. That is selection sort, bubble sort, and insertion sort. So these are not the best way to sort the array, but we should be knowing them because a lot of times in interviews you can be asked question based on them. So it's good to know. Okay. So we'll start with the very first idea, that is selection sort. Ki how we can sort this array using selection sort. Let's begin with selection sort. Okay. Now is this selection sort? We have this word selection. It means we need to select something. We need to select something. Okay. Now, if I ask you, we have to sort this array. We need to sort this array, right? So we have how many spots? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8. We have 8 kind of spots. Okay. Guys, if I ask you, what should come at the very first place? If we want to sort this data in ascending order, पहली place पे क्या आना चाहिए? We should have the minimum element of the entire array. Yes. What is the minimum element of the entire array? That is 2. Okay. So here 2 should appear. So what we can do is, we'll write a loop that will find the minimum element in this entire array. Okay. Once we find the minimum element, we'll bring it at the first place. So we'll swap these two. So 2 will come here and 11 will go there. Can I say after this step, this part is sorted and this part still needs to be sorted. Yes, this 2 is now in the sorted region. This is the complete unsorted region. Okay, great. Now, can we again repeat this step for this remaining part, for this blue part? Now, what should appear here at this place? The minimum of all these elements. Minimum is 3. So what we can do? 3 should come at the 11th place. So 3 will come here and 11 will go there. 11 will go there. Right? Now, can we say this 2, 3 is sorted and this still needs to be sorted? Okay. Again, repeat the same process, repeat the same step in this blue part, So in this blue part, guys, what is the minimum element? It is 11. So 11 should come here at the beginning and 14 should go there. Great. So what will happen? 11 comes here, 14 goes there. And now we can say this part is sorted and this part is still unsorted. We have to sort it. Great. Again, repeat the same step in this blue part. So in this, what should appear here at the first place? The minimum element. The minimum here is 14. So what we can do? We can bring 14 here and send this 18 at the place of 14. So we're swapping these two. And after this step, we can say this 2, 3, 11, 14 is sorted. This part still needs to be sorted from 20 to 40. Great. Again, repeat this step in this blue part. So guys, what should appear at the beginning? The minimum of all these elements, minimum is 18. So 18 will come here and 20 will go there. 20 will go there. We can say now the data is sorted to this 18 and the remaining part is still unsorted. Again, repeat the same step in this blue part. So what should appear here at the beginning? 20 should appear. Okay. The minimum element should appear. So 20 appears here, 27 goes there, we swap them, and we can say data is sorted till this 20. This part still needs to be sorted. This part still needs to be sorted. Now we come at 27. Again, find the minimum element. Minimum is 27 only. So we don't do anything. We swap it with itself. So nothing happens. And we say, now the array is sorted till this point, and this one element still needs to be sorted. Hmm. But guys, now do you think we even need to sort this 40? We have only one element left, right? So I think we can end the process here. We can end the process here and say the array has now been sorted. The array has now been sorted. Array has now been sorted. Like, is this idea of selecting the minimum element from the unsorted region and swapping it with the beginning make sense to everyone? So
वो सिलेक्शन शॉर्ट में हम क्या करते हैं, फाइंड द मिनिमम एलिमेंट फ्रॉम unsorted region of array and bring it to the current start index unsorted region. Repeat this process until last element of the array.
what we have done at every step is select the minimum in the unsorted region and bring it to the front by swapping it with the first element of unsorted region.
By swapping
Is this idea clear
with
for everyone? Yes or no?
start
Yes. Great.
index element.
Nice. Now let's move to the coding part for this. How we can write the pseudocode for this? Okay. First, we are trying to find the minimum element in the entire array. Yes. After the first pass, array is sorted in this point. Then we are trying to find minimum in this part, then in this part, then in this part, then in this part, right? Okay. All right. So let's start writing some code. Okay. First we are deciding what will come at index 0. Then we decide what will come at index 1. Then we decide what will come at index 2. Then we decide what will come at index 3, and so on. So we should write a loop starting from index 0 till index n I plus plus. Now we're deciding first of all what will come at index 0. Now to find that, we need to find the minimum element of this region. Okay. So we'll start a loop j. Now guys, this inner loop should start from which point? So initially we are at this index 0. We are at index 0 at this point. Okay. Then we're trying to find minimum in this 0 to n minus 1. Then in this part we should try to find minimum in this part, then in this part, then in this part. So while we are at index 0, we are trying to find, I'll just write it here. When we are at index 0, we are finding minimum in which part? From 0 to n minus 1. When our index is 1, when our index is 1, we are trying to find minimum in which region? From 1 to n minus 1. When I becomes 2, we are trying to find minimum in this part from 2 to n minus 1. So can we say for any index I, we should try to find the minimum in which part? I to n minus 1, I to n minus 1. Find minimum in the region, unsorted region, that is I to n minus 1, both inclusive, or you can say this is I to n exclusive. Okay, so how we can find minimum element in this part? So let's assume the minimum element is a of I itself, and let's write a loop starting from I or I plus 1, go till n j plus plus. Just have a check. That if this a of j is better than minimum, so update this minimum to a of j, update minimum to a of j, and once you are out, now we need to swap these two guys. For example, in the first pass, we'll try to find minimum from here. So this minimum will come out to be 2. That's perfect. Now we have to swap this 2 with 11. Now how do we know where is this 2 present in this array? Where is this 2 present in this array so that we can swap it? How we can swap it? We also need to maintain the location. Location is I right now. Here location will become j. Once we come out, we also have now the location of this element. Now we can swap a of I with this a of location. The location of this minimum element. That's it. That's how we can write the code for selection sort. I'll do a quick dry run so that it's crystal clear to you how this code is working. ठीक है, initially I is 0, so we are here, we have to find minimum in which part in this entire region. So what we say, minimum is currently 11, minimum is 11, perfect, and the location is also index 0. Now find the minimum with the location. This is the standard thing we have done already. So when you come out of this loop, the minimum will be 2, है ना, and location will be 1. So now what you do, you swap a of 0 with a of 1. So what happens, this 2 comes here and 11 goes there, perfect. First step is working perfectly fine. Then what happens, I becomes 1, now we want to find minimum in this region, so we assume this 11 is the minimum guy at location 1 and standard process to find minimum.
Okay, so let's do it in code now. Okay, so selection sort. Selection sort.js. Now create a function. इसमें हम एरे डालेंगे जो कि अनसॉर्टेड होगा. और हमें रिटर्न में चाहिए सॉर्टेड एरे. सो जैसा कि हमने देखा, सिलेक्शन सॉर्ट में हमें लूप थ्रू करना पड़ता है फॉर ऑल द एलिमेंट्स. दैट्स व्हाई वी आर टेकिंग फॉर लूप. I will be initially 0, then I will be less than. यहाँ पे हमें लेना पड़ेगा सॉर्टेड एरे. I will be less than sorted array dot length और I plus plus. इस फॉर लूप में क्या होगा, जो हमारा मिनिमम है, मिनिमम एलिमेंट, वो हमारा वही एलिमेंट होगा, राइट, I. So, मतलब सॉर्टेड एरे ऑफ I ये होगा. अब हमें क्या करना है, इसको कंपेयर करना है रेस्ट ऑफ द एलिमेंट से. तो रेस्ट ऑफ द एलिमेंट के लिए हमने और एक लूप लगाना पड़ेगा, राइट. क्योंकि अभी जैसे कि यहाँ पे ये एरे हमने लिया है, यहाँ आई ऑफ 0, मतलब जो पहला हमारा 0 आएगा एट स्टार्ट वो होगा 5. तो 5 को कंपेयर करना है रेस्ट ऑफ द एलिमेंट से. तो ये रेस्ट ऑफ द एलिमेंट को इटरेट करने के लिए और एक लूप लगाना पड़ेगा और लेट, यहाँ पे जे लेंगे हम लोग. और अभी इसमें क्या होगा कि 5 के लिए हम जब लेते हैं तो लूप स्टार्ट होता है 5, मतलब इसका जो इंडेक्स है +1 से. बाद में हम 6 को लेंगे तो इसका चलो होगा यहाँ से, इसका चलो होगा यहाँ से, मतलब जे होगा I, राइट. सही है ना, मैंने I+1 हो गया क्या, I+1 हो गया क्या, I तो है, I+1 होगा, फिर होगा J should be less than, yeah, sorry, J should be less than sorted array dot length on J++. अब इन लूप में हम क्या करेंगे, कंपेयर करेंगे sorted array of I if sorted. सो if लगाएंगे, if जो हमारा sorted array of I, sorted array of J, sorted array of J जो हमारा है वो अगर लेस होगा, लेस देन हमारा होगा sorted array of I से. तो हम क्या करेंगे, हमारा मिनिमम चेंज करेंगे और मिनिमम विल चेंज टू sorted array of j चेंज हो गया। तो फॉर एग्जांपल मैं यहाँ पे देखा तो 3 डालता हूँ तो हमारा sorted array of I है, sorted array of j है। तो हमारा sorted array of j जो है वो I से लेस है। तो हमारा मिनिमम इनिशियली 5 था, अब हमारा मिनिमम 3 हो गया है। तब हम इसको स्वैप करेंगे, राइट। तो इसको स्वैप कैसे करेंगे? तो इधर ही स्वैप करना पड़ेगा। तो स्वैप करने के लिए हम करेंगे लेट टेम्प इज इक्वल टू, स्वैप कैसे करेंगे भाई? टेम्प इज इक्वल टू सॉर्टेड अरे ऑफ आई, फिर हमारा जो सॉर्टेड अरे ऑफ हमारा जो सॉर्टेड अरे ऑफ जे होगा जो कि 3, वो बनेगा। सॉर्टेड अरे ऑफ जे लेना पड़ेगा हमें टेम्प में, और हमारा सॉर्टेड अरे ऑफ जे जो होगा वो बनेगा सॉर्टेड अरे ऑफ आई। और हमारा सॉर्टेड अरे ऑफ आई जो होगा वो बनेगा टेम्प, यानी कि सॉर्टेड अरे ऑफ जे। बनेगा टेम्प। तो ऐसे स्वैप होंगे। स्वैप तो बाहर होना चाहिए ना, मतलब आई में होना चाहिए ना। ये होंगे 0, हाँ। तो ये होंगे और पूरा लिफ खत्म होने के बाद हम रिटर्न करेंगे हमारा सॉर्टेड एरे। लेट्स सी। ओके, हमने मिनिमम यहाँ किया ना, तो यहाँ पे हम मिनिमम लेते हैं। पहला हुआ खाली। ओके, लेट्स सी। तो हमारा लोकेशन भी होना चाहिए क्या? इसका लोकेशन पहले क्या होगा? हमारा होगा आई, एंड यहाँ पे क्या होगा? जी। यहाँ पे क्या होगा? सॉर्टेड अरे ऑफ लोकेशन। Okay, let's see now. Yes, we are sorted. 1 2 3 4 5 8. ओके, तो इसको समझते हैं थोड़ा। क्या किया हमने, तो हमने पहले एक पेरेंट लूप लिया, फॉर लूप टू इटरेट थ्रू दी एरे, और उसके बाद हमने क्या किया, इटरेट किया, और हमने मिनिमम स्टोर किया जो कि हमारा पहला है आई। तो इसको समझते हैं। तो पहले हमारा आई मिनिमम हो गया 5। तो इस 5 के लिए हमने अनदर लूप चलाया जिसमें हमारा जे था i+1 दैट इज 3, और ये 3 कंपेयर करेंगे हम लोग 5 से, छोटा है इसलिए मिनिमम में 3 जाएगा, और लोकेशन में जे एंड या 3 का इंडेक्स जाएगा। उसके बाद 5 को कंपेयर करेंगे 4 से, और यहाँ पे क्या होगा, 5 में 3 जाएगा। ओके, 5 को 3 से नहीं कंपेयर करेंगे, जो 5 को हम ऑल ओवर द लूप ये करेंगे, कंपेयर करेंगे, और जो भी हमें मिलता है, अभी 5 को हमने 3 से कंपेयर किया, छोटा मिला तो हमने ये किया, लेकिन लूप फिर चलेगा। फिर 5 4 से कंपेयर होगा तो फिर 4 आएगा, फिर 5 2 से कंपेयर होगा, फिर 2 आएगा, 8 से कंपेयर होगा, कुछ नहीं आएगा, फिर 1 से कंपेयर होगा। तो अगर मैं यहाँ पे 1 इधर डाल दूँ, 3 इधर डाल दूँ, तो ये सही से चलेगा क्या? नहीं चलेगा भाई, हमें इसको ब्रेक करना पड़ेगा ना। यहाँ पे देखो 3 पहले आ गया, वी आर स्टक नाउ। ओके, लेट्स डू दिस। हम सॉर्टेड जी को आई से कंपेयर करने के बजाय मिनिमम से कंपेयर करेंगे ना, हम देखते हैं। यस यस यस, दैट वाज द मिस्टेक, क्योंकि मिनिमम तो हमारा अपडेट होगा एक ही बार जब हमें मिनिमम एलिमेंट मिलेगा। मतलब हम अभी 5 को 1 से कंपेयर करेंगे, फिर हमें मिनिमम मिल गया, फिर हम क्या करेंगे, इस एक को 1 को 4 से कंपेयर करेंगे, 4 को 1 से कंपेयर करेंगे, 2 से कंपेयर करेंगे, हाँ ऐसा होगा। मतलब हम हम्म, से सिलेक्शन सॉर्ट हो गया, और सही है। सही है, बिल्कुल सही है। Okay, selection sort
Yes.
workout.
So once this loop ends, we will say, acha, minimum is 3, and whatever index it is, index will be 0, 1, 2, 3, 4, 5, 6. Minimum is at index 6. So you swap a of 1 with a of 6. So what happens? 3 comes here and 11 goes there. Perfect. In the next step, I becomes 2. Now we will find minimum from I to I equal to 2 till the last. Standard process again to find the minimum. Once you come out, you will say the minimum is at this index. This index is 0, 1, 2, 3, 4, 5, 6. Index 6. Okay. So swap this a of 2 with a of 6 and array becomes like this. You can keep on repeating this process until the array is completely sorted. Does this make sense to everyone? That how we're applying selection sort to sort this array? Yes. I'll do a quick poll to see how many were clear. Okay. So I'll say I'm seeing that some of you are not clear. Okay. So let me ask, guys, are you clear with the logic? I'll come to the coding part. Is logic clear? Is logic clear to everyone? I'm doing a quick poll for logic. The
Logic
logic
clear है.
27 340. ठीक है. Again. All right. The minimum of all these elements. So they sorted these elements. This now send this 14 at the place of 11. First bring 14 here and sort it in 20 there. 20 here. Great. Then this part is sorted and only this part is by swapping it with the first element of the unsorted region. Of the logic in this part is so can we say okay and so on. So when we are at index 0, we'll try to find the minimum in this entire part. So how to find minimum element in the array with its location? You can write a loop. You can also start from I if you want. There are no issues. You start from I. Okay. You find the minimum element. In the unsorted region by this code. Once you have the minimum with the location, just swap the current element a of I with a of location. Let's just see this code for a couple of minutes. Let me know if anyone has any doubts in this. I'll quickly open the chat section for it. Okay, run it to 0. Unsorted becomes 0 at the end. And a of I'll go. So we'll 2 with location 0. I becomes to find the minimum will again be at index 6. So you swap a of 6 with a of I. 11 comes here, 14 goes there. And this will keep on happening till the last, and the array will be sorted. Now you can also do j equal to I plus 1. That is also fine because we have already assumed I to be the minimum guy. So that is already considered. It is same as the thing we have done earlier. Let's say you are given an array and you want to find the minimum element. In that case, what we used to do was we said, acha, minimum is at index a of 0 is the minimum and location is 0. We write a loop. Now it's your choice. You can start the loop from 1 also or 0 also. Both are equally good. We'll say if a of I is better than minimum, update location, update minimum equal to a of I, and update location equal to I. Update location equal to I. To be the minimum guy, and we'll say bring, even if you guys bubble sort, bubble or adjacent status bubble sorter. Next thing you have to cover is bubble sort.
शॉट देखते हैं थोड़ा. मैं पानी लेकर आता हूँ. Let's start now. बबल सॉर्ट। अब हम देखेंगे बबल सॉर्ट। बबल सॉर्ट देखते हैं अभी क्या है।
Now what does bubble sort says is that it says if two neighbors or adjacent elements are in the wrong order, swap them. That's it. If two neighbors or adjacent elements are in the wrong order, just swap them. So let's do this algorithm with this array. Okay. So what we do? We start from this place. Okay. Now guys, we compare this 11 and 2. Are they both in the correct order or they're in the wrong order? If we want to sort this array in ascending order, क्या दोनों सही order में है? No, they both are not in the correct order. So do what? Swap them. So this 2 comes here, 11 goes there. Perfect. Now compare the next two elements. Next two elements. Are these two in the correct order? Yes, they are in the correct order. 11 is less than 14. Perfect. Move forward. Compare the next two elements. Are they in the correct order? 14, 18? Yes, perfect. Move forward. Are these two guys in the correct order? Yes, perfect. Move forward. Are these two guys in the correct order? Yes, 20, 27 is perfect order. Move forward. Are these two guys 27 and 3 in the correct order? No, they are not. So do what? Swap them. So 3 comes here, 27 goes there. Perfect. Move forward. Compare next two neighbors. Okay. So these two guys, are these two guys in the correct order? Yes. Great. Move forward. Oh, now we're out of the array. There is no next element. So the first pass is done. So first pass is done. And we have the array like this. Okay. Great. Now let's keep on repeating this until the array is sorted. Again, we start from the beginning. Yes, are these two elements 2, 11 in the correct order? Yes, order mein, we can move forward. Are these two in the correct order? Yes. But yeah, let's move forward. Are these two in the correct order? Yes. Go forward. In the correct order? Yes. Move forward. Are these two guys 20 and 3 in the correct order? No. So do what? Swap them. 3 comes here, 20 goes there. Amazing. Compare these two. Are they both in the right order? Yes. Great. Move forward. Are they both in the right order? Yes. Great. Move forward. Okay. Oh, now we have reached the end. There is no next element. So second pass is also done. Second pass is also done. Great. Let's again repeat this process. So again we start from the beginning. Are these two guys 2, 11 in the correct order? Yes. Same order. Move forward. Compare 11, 14. Yes. Correct order. Do nothing. Move forward. Are these two in the correct order? Yes. Move forward. Next is 18, 3. Are these two in the right order? Yes. Oh, no. 18 is bigger. So what we should do? We should swap them. 3 comes here. 18 goes there. 18 goes there. Move forward. Are they both in the right order? Yes. Correct order? Yes. I think the remaining part is fine. Reach the end. We can stop. So third pass is also done. Let's move to the next pass. Compare these two. 2, 11. Perfect. No problem here. 11, 14. Perfect. No problem here. I'll just remove this. 14, 3. Yes. They're in the wrong order. So do what? Swap them. 3, 11. Correct order. Correct order. Correct order. Correct order. End of the array. Great. This pass is complete. Go to the next pass. Compare these two. Perfect. Oh, here. Or did I miss something? 2, 11, 14, 3. Oh, this should be 14. This should be 14, not 11. We start it. Okay. So these two in the perfect order. Great. In the wrong order. Swap them. In the correct order. Correct order. Correct order. Correct order. Correct order. So this pass also ends. Let's do the one more pass. Now in the next pass, if you see, everyone is in the correct order. Everyone is in the correct order. So we can stop. We can stop and say the array has now been sorted. The array has now been sorted. Okay. Is this idea making sense to everyone? A little bit sense that what we're trying to do? We are saying that if two neighbors are in the wrong order, just swap them and keep on doing this until the array is sorted. Until the array is sorted. Okay. Let's see a better example. Let's see a smaller and better example. Let's say we have 10, 2, 4, 12, 6. Let's make this maybe 2. Okay. Let's try to run this algorithm for this array. Okay. So we start with these two elements. Are they in the right order? Yes. Perfect. Move forward. Are they both correct? No. 4 should appear first. So we swap them. 4 comes here. 22 goes there. Great. Now compare these two. Are they both in the correct order? No. Swap them. So 12. 22 goes here. Then compare these two. Are they in the correct order? No. Swap them. 6 comes here and 22 goes there. Now there is no next element. Guys, can I say after the first pass? After the first pass, what has happened? What has happened after the first pass? Can I say this part of the array has been sorted and this part still needs to be sorted? The largest element, I can say after every pass, the largest element of the unsorted region will reach at the end. Yes, let's see this in the next step as well. Okay. The next step, we again start from the beginning. Start here. Compare these two. Are they both in the right order? No, they are not. So swap them. 4 comes here. 10 goes there. Great. Compare the next ones. Are they both in the correct order? Yes. Great. Are they both in the right order? Yes. Oh, no. 6 should come first. 6 comes here. 12 goes there. Compare these two. Are they both correct? Yes. Go forward. End of the array. Great. Now we can stop. Now can we say these two elements have been sorted and this part is still unsorted? Yes. So now array is getting sorted from the back. Okay. Let's repeat the same process. Let's do the next pass for this. Compare these two elements. Are they correct? Yes. Are they correct? No. Swap them. 6, 10. Are they both correct? Yes. Are they both correct? Yes. Out of the array, we can stop. Now we can say this part of the array has been sorted. Only this part is left. Only this part is left. Great. So let's again do the same process. Compare these two. Are they both in the right order? Yes, they are. Are they both correct? Yes. Are they both correct? Wait a minute. Do I even need to check further if I already know this part is sorted? Do I even need to go further? I think just comparing these two elements should be enough. Should be good enough. Right? Because this part is already sorted. So no need to go ahead. Just check for this unsorted part. Just check for this unsorted part. All right. So let's see what is happening. Initially the complete array was unsorted, right? Initially the complete array is unsorted in the beginning. Unsorted is 0 to n minus 1, the last part, right? What is sorted? Nothing is sorted. Okay. Then once the first pass is completed, we can say the last element is now sorted. Or I can write like this, key n exclusive, or let's write this only. 0 to n minus 1 is unsorted. Okay. In the next pass, when we reach here, can we say now 0 to n minus 2 is unsorted and n minus 1 to n minus 1 is sorted? This part is sorted. The next step, what will happen? This part will be unsorted and the next two elements will be sorted. So I can say the sorted region will be starting from the last two elements, that is n minus 2, n minus 1, and unsorted part is from 0 to n minus 3. This is now the unsorted part. Okay. Eventually, what will happen? If we continue doing this, what will happen? At the end, only two elements remain here, and this part is now completely sorted. Here we can say, at last, 0 to 1 is unsorted, and from 2 to n minus 1 it is sorted. We just do the last step. In the last step, what will happen? Only one element remains here, and this entire part is sorted now. So we'll say this 0 to 0 is unsorted, and 1 to n minus 1 is sorted. Like, is this progression clear to everyone? With how this algorithm will work? First, the entire array is unsorted, then this part is unsorted, then this part is unsorted, this part is unsorted, and eventually the entire array will be sorted. So now what we are trying to do is, on every pass, we are checking here what will come at, let's say, n minus 1. Then what will come at this last place? Then what will come at this second last place? Then what will come at this third last place? And so on. Okay. So what we can do is, we can write a loop. Instead of going from 0 to n, I'll write a loop from back. That I'll start from n minus 1. That what will come here at n minus 1 till what will come at 1. Till what will come at 1. I minus minus. Okay. Now, in the first step, I can say the entire array is unsorted. So here, if you see,